Ergodic process. So ergodic process is a random signal processing. Also, it's a stochastic process. So, what is random process? Random process, that means there is no pattern is repeated. Even we can unpredict the amplitude and what will come the next pattern. That is, we couldn't predict. And this one is stochastic process also. What is stochastic process? தோராயமான process in Tamil. So ergodic process is average statistical properties. For example, yeah, sorry. Uh, for example, if you going to consider that collection of data, you just take it from that. That means there is a whole data is there. Then you have to take the sample, that collection of samples, and take it at average statistical properties. So this is called as ergodic process. So that total sample of data representing like a bat's eye view. So ergodic process, it's a wide stationary for a constant mean. You can write it as mu of mu x e x comma t, and autocovariance, r x of tau e x of t minus ux x of t plus tau minus ux depends only tau and not on the time. The t property, what is mu? Mu means mean variance. What is mean? Mean, it's deals with uh, single signal. For covariance, autocovariance deals with two signals. For example, x of t is a single signal. If you want to take a average, mm, so the single signal information, you want to go mean function. If you want to relation between two signal, you have to go covariance, autocorrelation like. For autocovariance, so they given Rx of tau Ex of t minus mu x, then x of t plus tau minus mu x. The process x of t is said to be mean ergodic. The mean square ergodic is the first moment the time average estimate the mu of x is equal to 1 by t, the integral of 0 to x of t dt. The square mean mu x of t is 10 to t infinity. The autocovariance ergodic, that 1 by t integral of 0 to tau, the x of t plus tau minus mu x of t minus mu x of dt. A process which ergodic in the mean, the autocovariant, sometimes called ergodic wide sun stationary process. So this one is for discrete time random process. So the previous one is for continuous time random process. So for continuous time random process, it measured as t. For discrete time process, the time period measured as n. So discrete time random process, x of n, the ergodic, the mean value, if that mu x of cap equal to 1 by n, summation of n is equal to 1 to 10 to the power of n x of n. Convergence in square bit to assemble average e of x as a n to 10 to the power of infinity. So consider in Gaussian process, so Gaussian process, so you have to take the samples of data. For example, you just consider as a transistor. Transistor, you may take it 100 or 1000, whatever it may be. You just take the transistor and take it and find the noise depends upon the temperature. So so here they are taking resistor, not a transistor. Okay, resistor or transistor, whatever it may be, just take it. So they are okay. Here they are taking resistor, or we also taking the resistor. So the resistor, the thermal noise, it depends upon the temperature. So we plot the graph for each temperature. Each temperature we plot the graph. Then if you consider there's 100 resistor, then you have plot 100 waveform. So based on that, we have to draw only one single graph. The single graph give the information about average of 100 graph. So the calculating average value of the waveform, that gives you a time average. So these are the n waveform. There are n resistors. So if you take it, resistor is 100, then there is a waveform is 100. So based on 100 waveform, you just take it as average. That means you just take it as samples. Take it every graph. You just take a single sample, and finally you draw the graph or waveform. Then that's the average of that whole entire data. What is sample? Sampling is a piece of data. Take it from entire whole data. So similarly here, that piece of data, take it from every waveform. So we have 100 waveform. So from that 100 waveform, we taking the sample. Then finally we put it in one graph. That is we can call as the average of the whole data. So this things totally that first the only one average where graph give the information about statistical property of that entire processing. This processing we can call as here ergodic processing. So this give the assemble average of each plot. If assemble average and time average are the same, then it is ergodic. Now it give the assemble average for each plot. If assemble average and time average are the same, then it is ergodic. So do you understand the example of ergodic? Yeah. So first we saw ergodic function, and finally the mean variance, autocovariance, continuous time equation, and discrete time equation, and then example. Thank you.